We're starting into our lesson today's area of composite figures, lesson 8-5. Should be putting in this in your table of contents for page 78. Page 78. So you should be gluing on the left-hand side of your journal when we're done with the notes today. And don't forget to do that. And by the way, quite a few of you are not keeping up with your table of contents. You're not keeping up with gluing your pages in or number your numbers correct, and reminder that this is a test grade, completing your journal. And not only that, but you actually have to fill in the pages. If they're blank and you glued them in, you get no credit for those pages being in the journal. So test grade, easy one. Go back and watch all your videos or get on the website on the classroom and go ahead and fill in those pages using the hard copy notes. And it's okay to use the hard copy notes. I see some of you doing that and then watching the video, and that's totally fine. Good way to do it. So this is reteach area of composite figures. And so what we're going to be doing is finding the area of various figures. In the last lesson, you were finding area of circles and semicircles. Some of you struggling with semicircles, meaning half the area of a circle. But combining those areas together. And so this is what we do in real life. You know, houses might have like a circular breakfast area, and then this might be the living room. And so if I'm going to carpet this area, or if I'm going to lay tile on this area, I have to calculate the area of the entire shape. And so a lot of what we do in our real world, our shapes that we deal with are not regular. They're composite shapes. Regular, I mean like that's a simple half circle or a full circle. We put those pieces together and we find the total area. So one of the formulas that you may not have a lot of experience on, maybe due to COVID, or just not having as much experience, is the area of a trapezoid. And that's when you're calculating the formula 1/2 times height times base 1 plus base 2. And again, this is found in your formula chart front of your journal. And you want to probably flip to it. And I'm going to flip to it right now and make sure that you know these formulas. So I'm going to the area, and this is trapezoid right here. And it's got 1/2 B1 plus B2 times height. Now, the reason I'm showing you this is because if you look at the example they did here, they actually put the height up front. But remember that in order of operations, order doesn't matter on multiplication or addition. Now, I do have to do what's in parentheses first, but normally, honestly, I don't know why the makers of this worksheet did this. Normally, we would have the H out here, which is what the formula is showing on your formula chart. And again, order really doesn't matter. So technically you'll still get the same answer, but that's the way you're going to see it on the formula chart. So the formulas you need are area of a trapezoid, area of a semicircle, which is 1/2 pi r squared. You definitely need to know that if it's not half semicircle or half a circle, that it's pi r squared. You know that you're going to find the area of different things like triangles. And so I'm going to put that on here because it's not on this review. It is on your formula chart, and area equals 1/2 base times height. And that's the height of the triangle. And usually heights are shown with these dotted lines. If the height doesn't have a dotted line on it, that means it's a right angle, and that would be your height. So when you go to the nurse's office, you always take your height as a 90-degree angle. So whatever that object is, it has to form a 90-degree angle, and that's your base, and that's your this is your base and this is your height, how tall something is. And how you measure it is with a ruler or standing up against the wall and marking it. So you have your base and your height of whatever shape you're dealing with. And so you can see right here, you've got a 90-degree angle, then this is your base and this is your height of your trapezoid. So this one's a little different on trapezoid because you have base 1 and you have base 2, and you combine those two lengths together. So it's 14 plus the 18, and then you multiply by the height, which is 10. So this is your height here. And so this is your base 1 and your base 2. And so you're combining the length of the bases first, and then you're multiplying by the height and taking half of your answer. Now you can, if you want to, take half of numbers quickly, because remember, order doesn't matter. So just a reminder, though, that you do have to do order of operations parentheses first. And with the semicircle, you have to do the radius squared first because that's order of operations and you have to do exponents before you do anything else. So just back to some reminders there. So we're going to calculate the area of some of these figures here and see if you've got it. And again, we've got the area of the triangle formula. I'm assuming that you guys all know the area of a rectangle. But if you want to put that on this page, it would be probably helpful to you. Is area equals base times height, or sometimes we say area equals length times width. Length and width are the same as the base and the height, just different letters meaning the same thing. And that also works for a square. Rectangles squares are specific types of rectangles, but on a square you can also do side times side or s squared. So just some things to remember. And we're going to go over here and calculate. Now, one of the shapes that I don't have written up here is a parallelogram. Parallelogram is on your formula chart, and it does the same thing as base times height. So I'm going to put parallelogram here as well. It's the same too as the area of a rectangle. Parallelograms are just rectangles squished down. So if you take, for example, this shape on number 1, it is a box, you know, when you take them apart and you fold them down flat, how they just kind of move. This is just a rectangle that's been squished over to the side. And so it's giving you the height right here. So this is h, the height, and you're multiplying it by the base, which is this right here. And so that's going to give me the area of just this parallelogram right here. So I say to myself, okay, area of, and I'm going to draw a little picture of the shape so I know which one I'm dealing with. And I'm going to say it's base times height, or BH. And so it's simply 8 times 5, which is 40 millimeters squared. And we're back to write the formula, plug it in, and solve. And some of you don't do that, and you're going to start making mistakes, I promise you. So this one's going to be area of a circle, and we're going to say it's a half circle. So I'm just going to draw a little drawing there. And I know that if it's the half circle, it's 1/2 pi r squared. It's half the area of a square, half the area of a circle. And remember the little funny joke, pi r squared, no pi r round, ha ha ha. And so this is the area of our circle, and we're just doing half. So 1/2 pi, and we can use 3.14 times the radius. And again, if you notice, this is giving me d, or diameter. And so in order to find the radius, I have to half the 6. So in actuality, the radius would be 3. So I'm going to take my 3 and I'm going to square it. And 3 squared is 3 times 3, or 9. So area of my circle is 1/2 3.14 times 3 squared, which is 9. Now, oops, put another parentheses. So I'm multiplying all those. This is taking more than 3 steps, and sometimes it does. I'm going to take 1/2 of 9 because I know that that's 4.5, and I can do that one easy in my head. And it says multiply by 3.14. So I'm multiplying 3.14 times 4.5. I know that I'm going to move my decimal 3 places on my happy memory cloud. Some of you having problems with multiplying. 4 times 5 is 20, carry 2. 5 times 1 is 5, and 2 is 7. 5 times 3 is 15. Hug, kiss. Make sure you're with me. The next step is 4 times 4 is 16, carry 1. 4 times 1 is 4 plus 1 is 5. 4 times 3 is 12. And I add these together. And so I get 13, carry the 1, 10 and 1 is 11, carry the 1, 2, 3, 4, and a 1. And I move my decimal 1, 2, 3 places. So 4 times 3 is, I know, roughly 12. So with the decimals, it went a little over, and that seems reasonable. So again, I'm just doing a semicircle here, not a full one. So I'm going to draw a picture. So I've already halved the 9 and got the 4.5 times 3.14. Gives me 14 and 1300ths. I don't need the 0 back here. It's not necessary. Okay, now that's not my answer either. So I have the area of my parallelogram. I have the area of my semicircle. So then I'm going to combine them. They're different shapes, but they're making a composite shape. Composite means there's more than one thing going on. So I'm going to add the 40 plus the 14 and 1300ths. And just a reminder, you need to line up your decimals. And so I get a 3, a 1, a 4, and a 5. And that's 54 millimeters squared. And that's the combination there. Okay, so let's take a look at the next shape. I've got a triangle, and I know that area equals 1/2 BH. That's a triangle. It's half of a rectangle, and you can see it right there. And so when you see the 90-degree angle, that's what you're going to look for. This is my height. And my base, which some of you would say is not given, this is a perfect square. So my base here is 9. So area equals 1/2 of the base, which is 9, times the height, which is 6. And you can do this really easy by taking half of 6, and half of 6 is 3. I'm just going to do that. And 9 times 3 is 27 feet squared. There's my area of my triangle. And I probably could have done that over here. I'm going to stop for a minute and just so you know what I did there. And I have the 9 there. Okay, it makes it a little easier to see. And so there's my area of my triangle. Now I got an area of a square. And by the way, I should have probably said that was the triangles. And now I've got an area of a square. And I know that the square is base times height, or length times width, or side times side. And so it doesn't matter how you do it, but the area of my square would be base times height. It is a 9 by 9. Very easy to get that the area is 81 feet squared. So I'm going to add my 81 feet back to my 27. I'm combining the square with the triangle. So 81 plus the 27 for a total of 108 feet squared. And that's the area of the composite shape. Now I'll take a look at this little composite shape. We have a 7 by 7 here. So area of my square would be base times height. You're going to get really good at your formulas the more you write them down. So this is 7 by 7, and 7 times 7 is 49 miles squared. So that's the area of my square. And then I take a look and I have a trapezoid. And for those of you that don't know, this is called a right trapezoid because it has a right angle in it. And the reason why it's called a trapezoid is because it's got 2 bases and it's got a height. Now, the reason they gave you 14 across here was just to kind of mess with you. I do know that it's 7 miles from here to this point here. So if it's 14 all the way across, that means that this must be 7 miles there. And I need that for my area of my trapezoid. So area of the trapezoid, which is a funky shape, would be 1/2 base 1 plus base 2 times the height. And so the area of that trapezoid would be 1/2. Base 1 is the bottom or the top. It doesn't matter which one you use, but it's the one that's opposite each other's. It doesn't have the slants and they're parallel. So I could do 5 plus 7 and then times the height. And the height here is this piece right here. The height is 5. And so I have area equals 1/2. 5 plus 7, I have to do parentheses first, is 12. I can do half of 12, which is 6. So the area of the trapezoid would be 6 times 5, or 30 units squared. And so if I'm having a hard time with the drawings, I can just write trap to stand for trapezoid. That's just an abbreviation. So area of my trapezoid is 30 miles squared. So I'm going to add those two together. So I have 49 plus the 30 miles squared for a total of 79 miles squared. And I just put my answer final up there. And that was combining these two together. So just looking at what you're combining to find the area of the composite shapes. Number 4 has a triangle on top. So the area of a triangle is 1/2 BH. Now, you don't have to memorize these formulas. Look on your formula chart. They're all there. I'm an adult. I've memorized them. My base of my shape, my triangle, is wherever the 90-degree angle is with the height. So this one's the height of the triangle, 10 4/10. And the base figure is, if you notice at the bottom, is 12. It's 12 here, it's 12 here. So we got 1/2, 12 for the triangle, times a height of 10.4. So area of the triangle, 1/2 of 12 is 6. So it'd be 6 times 10.4. So I'm going to do 10.4 times 6. Going to go off to the side here. Ooh, happy memory cloud of 1. And I get to 6 and move it one place. So it's 62 and 4/10. So my area of my triangle is 62 and 4/10 meters squared. And then I say, okay, well, that's for the triangle. And I'm just going to draw a line there so you know that's for the triangle. Now I've got a parallelogram. So area of a pushed over rectangle. It's been squished. And so it's just simply base times height. So, whoops, in the case of the base times height, I just have to know where the right angle is. Always looking for the right angle to find the base and the height. I can't erase that. Sorry about that. So we've got here base times height. So area of a parallelogram, the base is either here or here. It doesn't matter. That's the bottom. This could be considered the bottom as well. So my base is 12. The height is where the 90-degree angle is formed. So that's how tall the shape is. It's 10 and 8/10 tall. So I'm going to do 10 and 8/10 times 12. That's 16, 1, 2, 0, 8, 0, 1, 6, 9, 2, 1. Move the decimal one place. And I get an area of the parallelogram to be 129 and 6/10 meters squared. And again, I'm going to find the area of the whole thing. The composite shape altogether is 62 and 4/10 plus 129 and 6/10. And just a reminder, just make sure you line up your decimals. There it is lined up. 6 and 4 is 10, carry the 1. 9 and 10, 11, 12, carry 1. 6, 7, 8, 9, and a 1. So I get 192. I don't need the 0 there, so it's simply 192 meters squared. And I'm done with that composite shape. Now there's one thing that STAR loves to do, and that is to give you a shape and then actually have you pop out a piece. So instead of adding the two, we'd actually be taking it out. It's kind of like a donut hole. Donuts start as circles, and then the holes, they take out the center part. And that's how they make their donut holes. And so we're taking a look and we can say, oh, can I find the area of the whole thing? So imagine this was colored blue all the way up. We know that it would be the area of a rectangle for sure. And the area of a rectangle would be base times height or length times width. So I know that the base is a distance of 18 and the height is 8. So I'm going to multiply 18 times 8, 64, 144. So I get 144 inches squared for the area of a rectangle, and I'm just abbreviating instead of drawing, it's fine. 144 inches squared, and so that's the whole blue thing. So to find the area of just the blue here, taking that piece out, I'm going to subtract the triangle. So I'm going to go area of a triangle is 1/2 base times height. So 1/2 BH, the base again is of the triangle I'm looking at, is a distance of 8 inches. Whoops. And the height is how tall it is. And so you look for that 90-degree angle. And again, if this distance over here is 8, this is 8 here as well, because it's a rectangle. So the sides are the same here and here. So it's 8 times 8. So the area of the triangle, 1/2 of 8 is 4. 4 times 8 is 32 inches squared. So instead of adding the two, because it's not added onto the rectangle, it's actually taking the triangle out or away. So I would take my 144 and subtract 32 from it, and I'd wind up with 112 inches squared. Now there is a different approach to it. I really honestly, if I just wanted the blue part, I could have calculated the trapezoid and done the area of a trapezoid, because you have base 1, which is 18. You have base 2 by subtracting 18 minus 8. You know this distance is 10 right here. And so I actually, and I'm just going to show this in one other way, I could have done 1/2 base 1 plus base 2 times height, and it still would have worked. 1/2 base 1 is 10 plus 18 times the height is how tall the trapezoid is, which is 8. So sometimes this works. So it's 1/2, 10 plus 18 is 28 times 8. I can take half of either the 28 or the 8. I think I'm going to do the 8 and make this 4. And so it'd be 28 times 4. And it would still give you the 112 inches squared. So this is just another approach, is just to find the area of the trapezoid if you can see it. If you can't, then just know that you can find the area of the whole entire rectangle and just pop out that triangle, okay? And so there's lots of different ways to do some of these missing pieces, so just look for that. If you have any questions, let me know, and make sure you're using your formula chart. Lots and lots of formulas today. Y'all take care. Make sure you glue this in. Get your journal caught up. All right, we'll see you next time.